Are we buddies now?
We have, yeah. So, new place.
Yes, Compass offices, 16th floor, Lee Garden 2.
The only reason is because it's closer to me. And also it's very nice of the Compass studio.
Yeah, and the story is, sight unseen, they accept my LinkedIn message, don't know me, and I say, hey, I'm around. Can I just stop by and chat about shooting? And I forgot his name. Eric? Jay?
I don't know. You met him.
William. There's so many.
William.
Yanis, Rachel.
There's a lot of you guys from Compass Studio.
So gracious. Sat down, saw the Hong Kong AI podcast, what we were doing at Aki Labs, and immediately agreed to set us up with this wonderful corner office. And so, and we're very happy to be here.
And actually, Compass Studios do host quite a lot of AI related
events. Yes, Lunatics, AI Tinkerers, maybe not yet, or maybe they have. I'm not so sure. But yes, they host a lot of events, and also we had to do a fair bit to get this whole setup. Which
so we have
quite
a bit
crazy.
of a little new setup because Ricky's not around, so we're using other tags and. Let's see if it's any good. And I think the mic is definitely better. We're definitely upgrading. We have like a mixing board and so on and so forth.
Mixing board, and Andy was gracious enough to wait for us in the lobby while
so
we're
who
getting
is Andy?
So Andy, a long-time AI tinkerers, has a startup called 3 Points Compliance, but a long time did a lot of work with Hong Kong Exchange and setting up their initial set of terminals, PhD, knows a lot about everything, but I think we just get along because he likes improv and comedy, and I'm an older guy and I like that kind of stuff, you know.
So is this an AI improv session?
Well, they share a letter again.
Okay.
AI improv. So maybe Andy just told us.
Andy
Green just told us that he also used to do radio. So this will be a wide-ranging conversation. I think you guys will have a lot of fun. And of course, I'll be in the peanut gallery.
Yes.
Still.
Yes.
Okay.
Uncle Ok will be around.
Yeah.
Yes. So,
okay. Great.
Thank you.
Thank you. All right.
Andy?
Come on in.
Maybe I could promote my improv show we're doing.
You can promote
June
anything.
6th, which is the very first time in Hong Kong that I'm aware of. We're actually using AI in the show.
Are we like June 6th? Okay.
June 6th, yeah.
Okay.
So is that okay? Is that in the way?
Yeah. Hi, Andy.
Hello, Tanya.
So you do have a radio voice.
Thank you.
You do have a radio voice. So is Andy Green improv?
Well, that's one of my faces. I've been doing improv in Hong Kong for quite some time, and I enjoy it. It's a change from the high-tech world.
But you are a computer person for how long?
Yeah, I mean, I'm a computer person, but my first degree is in electronic engineering. So I'm first in electronics, and then
So you actually build chips and stuff.
That's right. In fact, exactly. I was a chip designer in my very early days.
Where did you go to school for WE?
I went to University of Essex.
Okay.
And then when I completed there, I stayed on as a member of staff. And actually, I became a member of staff before I got my PhD. And I did my PhD in parallel with being a member of staff.
Wow. So you must have been very good.
I hope so.
And so you were in WE, and then how did you move from actually building chips to being on the software side?
Well, I was a student apprentice with Marconi Communication Systems, and during that time I also moved to Marconi Electronic Devices. So I was building integrated circuits or designing integrated circuits with that company, and that's why I learned to design ICs. And I got interested in AI at a very early stage. I think I was doing some of the first courses in the UK, master's courses in machine learning and expert systems and genetic algorithms. So, and then I got involved in some conferences, met some really smart people, and decided that AI was where I wanted to be, although we mostly called it machine learning in those days.
Yeah, so you're talking about like late 80s, early 90s?
Yes, I got my PhD in 1989. I probably started teaching courses about 1987.
And that's all in the UK?
All in the UK, Yes.
And so how did you get from the UK to Hong Kong?
Well, I reached a stage in the UK, the university system. You get a year sabbatical, and I was coming up for a sabbatical year as a university lecturer. And I had a friend out here in Hong Kong, very much involved in data distribution for the stock exchange. And he said, "How about you come out during your year off, as it were, and run a project at the stock exchange," which is what I did. And then I
Stock
stayed.
exchange?
Yes.
I mean, stock exchange is no jokes. That's not an amateur project.
It certainly wasn't, no. No, the project was to upgrade all of the terminals on the Hong Kong Stock Exchange floor in one weekend, which involved changing all the software. All the computers in those days, this was 1991, were based on the old BBC computer produced in the UK.
Yes, you mean there's the black and white screens with you program, right? You program in BBC language.
Yes, but actually there was actually a ROM, a chip inside it, which drove how the terminal worked. And we had to rewrite that completely and put it into a lot of machines that hadn't been opened or cleaned for quite some time.
Well, I actually did my computer studies on BBCs, so I know what they are.
Right.
I programmed a lift, I remember. But to be able to do that in 1991 means because stock exchange, it's only in the weekends that they don't work. That's the only window that you can work on.
Yes.
And it has to be highly accurate. Nothing can be going wrong because everything has to be up and running on Monday.
Yeah, I've done a lot of projects like that since. But yes, very time critical. It was a busy weekend.
So did you had a really good time, 1991?
Yeah, it was a lot of fun. It was a very interesting project.
How long was the project?
I think it was around about 18 months.
So you got to see the Hong Kongs in the 90s?
Yes, that's right, yes.
And then you went back to the UK?
No, I stayed here. I've been here 34 years.
Oh, so you just never left?
I just never left.
So you must have had a really good time.
I had a great time, yes. I arrived with my wife, Moira, long-suffering wife, Moira, and my 2-year-old daughter, Abigail.
So, my goodness, you are a true Hong Konger.
Well, in a sense.
Well, you've been in Hong Kong longer than I do. So how did you go from stock exchange to AI?
Well, no, I was already involved in AI, but the stock exchange project was just too good to miss, really. So I worked in that company providing trading technology, and then we sold that company to Reuters. And then I acquired with a partner, I acquired Motorola Data Tag Network. So, and then I've done a variety of different projects through my time here, including designing the wireless betting systems for the Hong Kong Jockey Club.
Oh, really?
Yes.
Wow. You are like really hardcore projects, right? It's like there's like no fail project.
Super critical projects where it all has to work out. Yes.
Yeah, do you get backdoors for wireless betting? Like,
Of course not. Of course not.
Yes, no, just joking. It's like the Hong Kong Jockey Club.
The trick
is
of
very, very
security
tight.
is to not let anybody have a backdoor.
Well, I think what's unusual about Andy is it's like hardware and communications side. Because when you think of AI, it's very software focused most of the time. But this is sort of like you come up from the ground up almost from the hardware and the networking, wireless comms, and then AI. Yeah.
Yes, but there's a lot of software associated with telecoms as well, because there's a lot you have to think about to be able to sell a service. Particularly in those days, you remember there was no GPRS.
What's GPRS?
GPRS is the data service before 3G on GSM.
Oh, that's right. I think I remember seeing that on my phone.
Yes, a walk through memory lane telecom.
I don't think your phone
systems.
switched to GPRS anymore.
Oh no,
at one point your phone would drop to GPRS.
But you don't see that
I think you've got to be in the middle of the Arctic nowadays for it to drop
it's
to
like
GPRS.
your phone, the lowest your phone would drop is 3G. Okay?
Exactly.
By the time you get to 3G, you know your network is bad.
Yeah, I think that probably indicates how much it's moved. Bear in mind that in those days, people were buying data in megabytes or even in kilobytes.
Oh, yeah. I don't know about a kilobyte, but I remember buying data in megabytes.
No, seriously, in kilobytes, because no one was even having wireless email in those days. Remember, this was pre-iPhone. The iPhone made a radical difference to the entire data market. But before that, our main clients on the network when we acquired it were DHL, UPS, TNT, FedEx, these sorts of companies that were doing it for dispatch reasons. To do it for something like wireless betting was pretty innovative.
Yes. Yeah. So you started with that black and white thing, right?
The little black device, yes,
yeah,
the TWM.
That everyone in Hong Kong knows, called 投注寶. They're really I think a lot of older people in Hong Kong have a lot of fond memory with
That's
them.
very hurtful, Tanya. The older people. Yes.
No, because nowadays it's on a phone now.
Sure, of course, but in those days there wasn't anything like that.
Everyone loved it. It was a very stable technology, and because everyone gets super excited. With their bets, So it has to be solid.
Yes, it was a very, very solid application. It had to be.
Yeah.
And here's something quite interesting for the techie nerds. I think it's probably one of the very, very first times I'd actually seen production Python servers.
It was on Python?
It was a Python server.
Very risky.
Oh my goodness.
I would say. Yeah.
It wasn't actually, because we really, really audited it very carefully.
Okay,
but yes,
good.
it was a very early use of Python.
And because I don't know, this is for everyone who's from Hong Kong, probably you know this already, but for anyone who happens from overseas, you might not know how serious we take horse race betting and also the amount that involved, because in Hong Kong, one single race, the bet amount is probably a season in South Africa. Or because I have friends that comes in from South Africa and they look at it, they go, "This is the amount that you guys are betting per race," and we're like, "Yeah, then that's amongst the whole season." So, and you have and the prevalence is huge, is across the population, and it has to be working all Hong Kong through the phone line, so remarkable.
Yeah, and all the devices, of course, had an ID number, and I have to say, device 888 was very popular.
888, 8888, yeah. Those are probably specials. So yeah, you know your things. So you had a front row seat looking at how AI was something that no one really talked about, to the point that right now probably the lady down the street who's selling your fruits probably have ChatGPT in her pocket.
Yes, it's interesting. When I first got interested in AI, I was very, very lucky. There was the head of Cambridge Engineering Department was running a conference in the UK. It was the first IEEE conference on neural networks, and he invited me to join the committee. And that was terrific. I remember going to see my Vice Chancellor and saying that I wanted to do this and get involved in AI. And I got "Are you sure this is a serious area of research that you should be involved in?" Which is quite funny when you think about it nowadays. But honestly, in those days, we'd been through the AI winter, or we were well in the AI winter.
When was that?
Well, it's difficult to say exactly when the
90s?
AI winter was, but certainly you're considered a bit of a fringe person if you're involved in this sort of area. Expert systems were okay, but neural networks, I was in what in those days was loosely called biologically motivated computing. Now, biologically motivated computing includes neural networks, it includes genetic algorithms, and it includes any sort of computer model that may in some way be related to how we believe the brain works. Honestly, we're guessing half the time, but we certainly notice that there are neurons, there's high levels of connectionism, sometimes also called connectionism. That was another label that was there. So the label AI, although it was developed in the 50s, it wasn't quite clear what it covered. And I suspect it's been like that ever since, to be perfectly honest, because Are LLMs AI? I guess, but in some ways they're not. In some ways they're just a part of it. So there are all these different facets, and they've been loosely labelled under AI, but it's a very broad brush.
To echo Andrew's point, like the focus when I was studying cognitive science, it was actually we were trying to understand the brain. There was it was a heavier biology, neuroscience focus, because our computers were sort of simple, so we were just trying to do simple problems, and we just couldn't do too much. But then over time, especially with the recent advance, like attention is all you need, and all these other recent advancements, now it's getting to a level of intelligence that's quite robust and surprising. Yeah.
Well, I guess we'll get to talk to this a little bit more later. But I'm very interested in the way things have developed. I'm very interested in emergent behaviour, and I think a lot of what we're seeing is emergence that we could have had no idea that we would have seen before. So in the neural network world, for example, I was working in neural networks in 1998. Yeah, what that'd be 1998. No, that'd be 1988. I'm sorry. I'm very bad at dates. I apologise. I'm quite good at order, but I'm poor at dates. My wife does the dates. And we were dealing with like 20,000 neurons, and we were seeing certain sorts of behaviour which looked like memory and looked like storage, but we were seeing nothing like we're seeing today. And of course, we had absolutely no idea that we needed to have, 500 million, 1 billion before we were going to see anything very interesting. And really, a lot of what we're seeing now in AI is all related to the fact that the two things we knew we didn't have, we now have. One was cheap processing and memory, and the other was data. And really, in those days, we didn't have either of them. And now we have both of them, and suddenly these things come together, and we've got the opportunity to see real emergent behaviour. What further emergent behaviour we'll see is interesting, but what I don't think anyone realised was how much intelligence is coded in language.
Oh, yes. Language is a form of compression, you can say.
Well, but on the other hand, didn't they digitize the fruit fry's brain, like a fruit fry? Like they digitize the fruit fry's brain, and there's something like 17 million connections, and then without any programming, the fruit fry is already functioning on its own. In this digital environment of its, and then the conclusion of that is that if you have all the neurons and you'll have all the synapses, the being will be behaving the way that it will behave.
Yeah, that is, having been involved in biologically motivated computing for as long as I have, that's a huge jump of logic. That's a bit like trying to deduce the shape of an entire human being from a toenail clipping. Will if you took that nail and put it in water, would it grow into a human being? I doubt it.
Not so much about human being, but at least a fruit fry, it seems to function just the moment that all the neurons are there, and it seems to seek out light and seek out food, and it seems to behave that way by itself. I'm not sure about human being. But it's just, it was interesting to see.
I mean, certainly extremely interesting, and all this research is interesting. And even in the early days, I can remember that some of the sort of closest and friendliest colleagues I had who were interested in looking at AI were not actually in the engineering department. So a good friend of mine who you may see occasionally on television these days, I don't know if he's retired, was Professor Noel Sharkey, and he was at University of Essex and very, very interested in language and also very interested in observing people who had problems with their brain. And I also did some work with a couple of other neuroscientists, and we visited hospitals and met people with most unusual damage to their brain that achieved some really, really strange results that maybe give you a clue as to how some of these systems work. There was a particular person who just couldn't interpret prepositions. So you could say, I want to put these glasses on the cup, and they'd hear glasses and they'd hear cup, but they'd have absolutely no idea what on meant. even though you could show them and then you could use the phrase again and they still couldn't remember. So really specific damage to the brain.
They don't remember the language describing the positions, or they just don't. They can't understand spatially related that.
No, they attribute no information to those words.
How interesting.
It's the difference between sort of like a pictograph and an ideogram, right? Like a pictograph is just describing the object, cup and glass. Ideogram is like a concept. It's on. How do I? That to me would probably hit a different part of the brain, right? Yeah.
Yeah, and this person had a very specific stroke, and it had damaged a particular part of the brain, which was very interesting because it indicated that actually the storage was quite specific and related. And of course that work in neural networks has been continued. I know I was listening to William, who also appeared on this, and he was talking a little bit, if you remember, about looking at the parts that light up.
Yes.
And Anthropic did quite a lot of work in that area, and even in the very early days we were doing that sort of stuff.
Yeah, there's this jargon in AI research called an ablation. This is like a physical ablation where something changed in their brain, but usually we just do it for experiments and trying to figure out how things work.
Yeah, and actually my paper in that conference I mentioned in 1989 was talking about putting small neural networks together that had particular functions and then retraining them to achieve a more complicated function. So actually, even in 1989, that sort of thought process was a little bit there. To be perfectly honest, we had so little processing and so little data that was... I had, on a university grant, I got a card from a company called SAIC that plugged into the back of a computer, and it was basically a supercomputer on a card. And I could simulate 20,000 neurons. I had people coming from other universities just to come and see it.
Yeah,
it was great.
And I remember when I was in college, like 20,000 is a lot.
So it was a lot.
Massive amount for. I did not get to that scale for my undergrad project. Not
And that was what, 20 years ago?
91, mid 90s.
Yeah. And so it's really, there's a huge jump from that, right?
Oh well, now of course we've got so much processing power. We walk around in our pockets with more processing power than the Apollo program had. So So is it weird for you to see how this progressed, or is just like, because it like you say, for a while it was fringe. It was a fringe research, and people might even look at you funny, if you are in this part of research. Yes.
And then all of a sudden it becomes so prolific that everyone is talking about it, and everyone seems to have their own interpretation and their versions of it.
Sure, and even people who are in it relatively recently can bring new knowledge. But it is interesting how many sudden experts have turned up. So not everybody who says they're an expert really understands it. And I think
that's a very polite way of putting it.
and the other thing, of course, is that so much of it is unpredictable. So nobody could have predicted that. Maybe someone could have predicted that orchestration was going to be the next big thing. I think I had a feel for this in the sense that in the early days, we were playing around with like individual neurons, looking at sigmoid functions and how to simulate neurons. The solution that we came up with was quite interesting. And then we were looking at networks with them connected together. Then we've got lots and lots of those connected together, and we get LLMs, or perhaps small language models followed by large language models. And now we're getting orchestration.
What's the difference between small language model and large language model?
They're a lot smaller. They take a lot less processing. They're a more restricted data set, and you're trying to get something specific out of them. So it was mentioned in the introduction very kindly that I have a startup company with my partner Trini So, who is a very experienced compliance person. And I think this is the model for an AI-first company, to have someone who knows the tech and someone who knows the domain. And she's a domain expert in compliance. And we built a complete compliance suite for SFC licensed companies in Hong Kong to monitor their employees' trading behaviour and conflicts of interest and all the stuff that's involved there. And all that code has been developed by AI, and the company is run fundamentally through AI. So that is the sort of model of these sorts of things. But back to the small language model. So if you wanted to look for a particular compliance issue in a data set where the data set was constrained, you might get a small language model, because you don't need to know everything about language. You just need to know about the subset of language you use in that particular domain. So that allows you to have a smaller number of neurons and to be more targeted for a particular result. Large language models are basically huge amounts of data. Saves costs, saves processing, and can actually produce a better result because you're not trying to do everything. So therefore it is constrained.
Is that how DeepSeek is doing? Because like DeepSeek it seems to save, like have certain way to save costs, right?
Oh, okay. Well, we're sort of wandering into multiplicity of experts issues, where you have a network where you deliberately switch to only use part of it to reduce the number of neurons that you fire, and conceptually, it's sort of similar. You could argue that's a lot of small language models all glued together. Someone who actually did that will probably argue with that definition, but it'll work for now.
But for a person who knows nothing, that sounds not the same. But for the expert, there's a huge difference in between.
So small language model, then large language model, and now what we're starting to see with platforms, like Hermes, for instance, we're starting to see the usage of a combination of different LLMs, maybe different LLMs at different levels, to all come together in some sort of problem solution. So that's where you could say orchestration is a really good phrase. It's like having an orchestra. Each one of the LLMs is like an instrument, and you're playing a tune and you're asking each part to play its part.
I saw someone that showed me a chat that they actually use several models, and then you ask the questions, and then several models will argue with each other. Mm-hmm. You can see them arguing with each other before they give you an answer.
Sure, and that can be a very good way to get rid of hallucinations, because you can have one expert that's answering your question, you have another expert whose only purpose is to make sure that answer is consistent, checks all the references, make sure they're actually real, and then you can have another expert that looks at it and says, does this make sense on the basis of everything I know? And if all of those agree, the likelihood of you having a hallucination, certainly the likelihood of you having a legal document stating a case that doesn't exist, the chance of that goes down enormously.
That almost reminds me of the Hindus' Vedas, the Vedas, of how they have, like the oldest Vedas is 4 Vedas, and they're actually all talking about the same thing from a different facet. So one is actually just telling you how to chant, and the other one is actually there to monitor to see if that chant has been conducted properly.
Okay, as a card-carrying Anglican Christian, I'm afraid I'm out of my depth.
Yeah, but it seems like humans always have that like ability to make sure that like the checks and balance, right?
Yeah, we've always been big on committees. It hasn't always worked, but we've generally been big on committees. Yeah. So
you went from like you were in electronic engineering. You went into softwares, and from softwares you came to Hong Kong and you start working in the early stages of AI. Mm-hmm. And then what? What did you do?
Oh, that's a very long story. Yeah. So.
How much time have we got?
Yeah. I'll try and do the abbreviated version, which isn't actually that short. I'll try and make it short. So, with a partner from the previous business, the data provision, we acquired Motorola DataTac, and funnily enough, CompuServe as well, but we weren't ready to get into internet, so we sold CompuServe. And we did the wireless betting, and we did the Hong Kong government's electronic road pricing trials, so we did a lot of vehicle telematics work. And
you mean like to help the vehicle pay?
Yes, to pay. Yes,
wirelessly?
Right. Yeah. My team designed and built the world's first GPS-based road pricing system used in an urban environment. So we built that here, and then we worked with the German government building prototypes for them for their system, which is called the Maut. That's all the German I know. Finished. And Yeah.
Is that like how in Germany isn't that you can pay to get on the autobahn so you can drive?
That's right.
fast
Yes,
as
they
you
have
want?
like a car radio that determines where you've been and works out the pricing. We work with Ford Motor Company, Visteon as our partner to build that as a trial for the German government, and then we acquired another couple of mobile. Radio companies in Hong Kong to roll all the frequencies together, and then we brought IDEN into Hong Kong, which is a push-to-talk GSM. So if you imagine a walkie-talkie, it's like a GSM phone that does the whole walkie-talkie. It's very big in America for quite some time.
Yeah.
And it's basically technology as used by companies like Disney and some systems in there and at the airport and other places. And as is the want of a serial entrepreneur, we exited that at some stage. and then I did work in GSM anti-fraud systems with a company called Neural Technologies, and a variety of different sort of startups and different activities. Just before COVID, I spent some time with a company called P2I as their CTO, and P2I were providing nanotechnology coating, and we were building robots for coating mobile phones and waterproofing basically for the phones. So this was a nanotechnology thick layer that goes on top of the mobile phone to protect it from water damage. Quite an amazing technology, to be perfectly honest. So we used to go around showing this off to people. I should have brought one today. We had tissues which were nano-coated. And we used to take a tissue, we used to push it into a glass of water and just shake it out, and it was completely dry. Yeah, so it was a lot of fun at parties.
It looks like magic.
It did look like magic, yes.
So if your improv doesn't go well, that's a life-saving tissue.
I never thought of doing that, actually. So now, actually, it's funny. Improv and AI are going to come together in a minute, but I'll explain how. So I was working, doing that sort of thing, and we were building the Razr phone, the lovely, beautiful phone.
Motorola.
The Motorola phone, absolutely classic. This was actually the new version was all screen, so it folds out and it's
silver and folds out.
Lovely phone, and we were building that and putting all the water.
Motorola has a lot of nice phones.
Yeah, some really nice devices, and this I have to say is very classic. And as you know, a dedicated Star Trek fan, which of course I would have to be, then there's something about the Razr phone, isn't there? So,
well, I had that circular phone. The one that had had a circle screen, and then
an interesting design that was. Yes. Yeah. No one copied it, which must say something. But anyway, it was an interesting design. But anyway, building the Razr, and we were doing all this water protection, and we had all sorts of robots, and it was a great system. And I remember sitting outside the factory thinking, that's great, we've got this working, everything's fine. I'll come back here in a month and come and have a look, because I've got a team there, they're running it all, that's fine. Of course, the factory was in Wuhan, so I never actually got back to that factory. But there you go. And so that was just before COVID.
Yes, I wonder why. So that's that right after COVID. Did you go? Oh wow, AI is going back.
Yeah. How did you meet Trini, for example?
How did I meet Trini? Well, Trini and I were both involved in the Hong Kong U's Lead for Life program, which is a really great program. This gives me a chance to say good things about it, so that's terrific. Lead for Life is what they call a character-based leadership program. And it's led by some really competent people who encourage students to think about the wider things you think about in life. So it's all very well to go to university and get a skill, but how are you going to exist in the world, and how are you going to exist in your company? Are you going to be aiming to be true to yourself? Are you going to aim to be responsible? Are you going to aim to be the sort of person, or are you going to aim to be the person, or well, no one really aims, but are you going to wander into a situation where your only interest in life is the money that you make, and your only interest with every relationship with everybody is how much you can get out of them? If you go into life like that, that isn't going to be much fun,
So you
and
mean
it's
Hong
probably
Kong,
not going
you
to be
have
successful.
programs like
They have a
this?
program, this Lead for Life program, which is absolutely excellent, and students go on it, and I think it's really beneficial. And part of that program is they bring in volunteers who mentor the group. And it's a mixture of both male and female students. You get about 14 to 20 students, and they match you with one male and one female mentor. And my mentor of my group was Trini. So we got chatting, and she said that she was interested in starting this company, and I talked about what I did, and we thought we could probably do something quite interesting together, and that's how we met. Yeah. So, and it's good because we both have a heart in philanthropy because that's where we met, and we very naturally take a similar, I would hope, character-based view to business.
So what kind of company is it?
I mean, first of all, thank you very much to Cyberport. It's a Cyberport incubator company, and Cyberport are very, very supportive. It builds AI tools for compliance for SFC licensed organisations. So to keep Hong Kong safe and pure in terms of how things are done from a financial point of view, we have the SFC who have a set of regulations that everybody has to follow, and that's terrific, and that's exactly as it should be. What we do is we try and make that needs to be done. It's a regulatory requirement. We try to produce tools that allow that to be done better, quicker, and more correctly. And we use AI to both build those tools and design those tools, and some AI within those tools.
So basically to save time.
Not only time, also to make sure that the information is correct and make sure it's collected as painlessly as possible.
So Trini was doing some manual stuff maybe at her previous life, and she saw, okay, there's a better way to do this problem.
Well, I think Trini was using the systems as available at the time that she was there, but we saw by looking at what was available that really something that fitted Hong Kong's actual rules was very hard to get. Even if you paid a lot of money for a US-based system and brought it over, you'd discover that it didn't actually do half of what, or half's not fair. It didn't do the things that really hurt. So you'd collect all your information on a system, and before you know where you are, you're on Excel trying to work out whether this was actually right. That isn't a good solution. So we concentrated on a good, well-encapsulated solution where all the parts talk to each other and where it matches the thought process of a compliance person rather than the thought process of an engineer who built it.
That makes a lot of sense. Yeah.
I mean, that's one of the things I talk about is this sort of the 80-20 rule, like building the 20% of software that solves 80% of the problem, because packaged software, they tend to want the customer to cater to the package. But with AI tools, you can actually build very tailored, specific solutions that are very targeted. Could you go into maybe the iterative process that you did with Trini and sort of developing this thing?
Yes, I mean, I spent time watching her say how she wanted to do it. And I started to think, okay, rather than sit down and say, yes, I understand this system and here's how it's going to be, I spend as much time as possible talking to her and saying, so, you know, you don't really like that, do you? So what would you really like it to do? Exactly. But also using my knowledge and experience about making software results really repeatable. So it's quite interesting. At the moment, there's a lot of talk about the death of SaaS, you know, as a result of AI, and some people are talking about
the death of what?
Death of a software as a service. I think I'm not a subscriber to that view myself, but I think it very much depends on what service you're providing. But actually, I think Alex was talking a bit like this. He was talking about you know, maybe you just have an idea and you just throw it into Claude, it would just build you your software. And I could see in certain circumstances that will be true. But if you want to get that exact edge and a real understanding of what's going on, there's still quite a bit of work to be done. Even though you've got the software tool to build the software.
I think there might be, I have an easier analogy for people to understand that, is that when 3D printer first came out, people say, oh, that's the end of anyone buying anything because I can just 3D print everything. And the reality is maybe there's like 1%, 1% of the population that will 3D print every single thing in their household, but the rest of us are still buying stuff.
Yeah.
So I think it's the same thing with
The Green Army soldiers, you can print that off.
Yeah, but I'm just saying that there will be people who are just building softwares, maybe you, that just building softwares tailor-made to everything that in your life. But I don't think, at least for the next 10 years, I don't think that will be the case.
Yeah, I think in AI, the word never is one you should definitely keep clear of, okay? because if anyone who says, well, it'll never do that, well, good luck with that. Yeah. And anyway, it's a null hypothesis, almost impossible to prove. Yeah, I think a very good example. Now, I've got a really good friend called Martin, and he really, really, really kindly gave us all lessons, me and a couple of friends, on how to bake our own sourdough, bread, which is, I have to say, if you haven't tried it, you really should. It's really good, okay. And everybody knows it's good, and everybody knows it's great bread because it's got none of those artificial things in. Okay, it doesn't last that long, but that's fine because you eat it, and it tastes really nice, etc., etc. So the capability to bake bread is there for absolutely everybody if you're prepared to look at a YouTube. There are still companies that bake bread, okay, and of course there are, because it's actually quite a pain to do, and it requires a pain, that's terrible. It's actually a joy to do, but it means you can't do something else with your life. So, you have to pick. So I think software is going to be like that as well. A lot of companies are going to say to themselves, yes, I could sit down and do this, and I could sit down and do this, but actually, this is the bit that's valuable. This is the bit I bring. And I'm not going to redesign a CRM system from scratch. I'm not going to redesign an accounting system from scratch, etc. I'm going to buy those because this is the bit I provide. So I think that's one of the reasons why I think software will survive for some time. As I said, never is a dangerous word to use. I'm not going to use it. So I think it's going to happen. In our SFC thing, we're based software, focusing in that area, there's something very important, and that is that we decide by AI that we need to follow a certain set of rules. But guaranteeing today with the technology that a piece of AI prompting will always apply those rules correctly is actually quite difficult. So the smarter way to do it, and the approach that we've taken, is to actually get the AI to write a piece of code that implements those rules. And then if we ever had to prove to someone we were following those particular rules, we've got the code to prove it. So the AI came up with it, the AI built it, but then the AI tested it to match exactly what it was, and I could close that loop. And then from then on, I don't actually need the AI because I've got the piece of code to do that particular thing. So we take that approach in a number of different areas in our software, and I think that's unusual because people are moving more towards pure prompting, but from a repeatability and guaranteed point of view, it makes a lot of sense.
Is that because that came from your experience of years working on softwares that require a lot of security, so that you have this kind of thinking? Because nowadays, I think one of the problem or one of the issues that we see is a lot of people started to design things with AI promptings that doesn't seem to have the security issues that in the back of their mind. So that leads to a lot of...
I think it's an engineering thing.
It's an engineering mind, and I think if you're in compliance, you have to be at least conservative with a small c, because you want to make sure that what you do is safe and reasonable. And I mean, to be perfectly honest, OpenClaw is wonderful. Who'd have thought that OpenClaw would have come out of Austria? I mean, when and that's saying nothing against Austria at all, but we think of all the people working in China, all the people working in America, and here we go, pop, and I think that is a real example. It's a fantastic idea, and I think it's a real example of how no one can really predict where this is going in the next 5 years. Because suddenly it's possible for people to pop things together and do things. There's all the question about, mythos and what that. And someone's produced open mythos, more power to them. And you see these sorts of things. You start to see some really small models doing things as well as some of the really large models. lots of questions about how much processing we're really going to need for local AI, all these sorts of questions. So I think making these guesses a bit of a mug's game, but at this particular stage where we are, to provide a secure and reliable solution for our environment, I know as an engineer what I need to do, because I've worked in security, a number of different security projects. Obviously, wireless betting is a security project fundamentally. GSM anti-fraud is also a security thing, and many of the other things I've done have had a security component. So that's what makes sense. But coming down to the end of this, I should promote that on June the 6th, we have an improv show, because as you kindly mentioned, I have improv is my hobby. I describe it as bleeding edge communication skills. Okay, and I think probably, I don't know if it's for the first time in Hong Kong, but the first time for our group, we're going to be introducing some AI into the actual show.
You're going to have AI with the improv?
Yes.
So the AI is going to decide what you're going to be improving?
And I'm going to say nothing else about it.
Very interesting. Let's take a quick break. And, thank you for Open Campus. Compass Studio.
Yes.
Well,
Jay and William and Kara and the team, yes.
Well, and we'll come back very soon.
All right.
Just take a quick break. Sure. So it's an improv show. Where is it? How many people are there?
It's going to be at the Black Lotus Studios, which is part of the Hive in Kennedy Town.
I'm not sure, because if you tell me a bit sooner, because normally the RTHK is very slow.
Oh yes.
Yeah, so if you can tell me like maybe like a month in advance, then I can interview you.
Okay.
And
we will do another one, but this is our first prototype attempt. So I've been meaning to try to introduce AI into shows for quite some time. So.
Are we good in good frame?
Yeah, I think so.
Yeah. So.
Okay, this is recording.
God, I miss Ricky.
Yeah, it's gonna be a little.
It's gonna be a bit bumpy today.
Okay, it's Chinese menu. What do I do here? Do I just click? Okay, that's a photo. Let me just keep going.
Are you not a fluent Chinese reader?
No, unfortunately. I got it.
You got it?
Yep. Okay, here we go. Okay, we're good.
Well, while we're on break, Andy, you told us about your first computer. I think that's worth recording. So can you tell us your first computer?
Yeah, my first computer was an Acorn Atom, and they used to sell it fully assembled or as a kit. And I unbelievably bravely bought it as a kit, and I soldered it all together and assembled it myself. And I'm still shocked it worked. If it hadn't worked, maybe I'd be an accountant today.
That's interesting.
How old were you?
I guess I'd probably be about 16.
Okay, 16. Okay, good.
Maybe, that sort of age.
And how about the punch card?
Oh, right. Okay, so yes, we were talking about the very first computer program that I ever wrote. I went to Brentwood School.
A very good school.
A very good school in the UK. So they were introducing students to computers really early. So the very first program I ever wrote was in Algol 66, which is a language that has
That sounds like Star Trek to me.
Yeah, it was...
or a new wave band.
Yes, Algol 66, yeah. Yeah, I was a drummer in Algol 66. Yeah, and because, we didn't have computers at school and we had to send our programs there, later on we got to do paper tape. But in the very early days, my first program was on cards, computer cards. You've probably seen those in the past.
That's almost just 2 steps away from like Ada Lovelace type of bomber machine, no?
Yeah, sort of. So basically the card, you took a 2B pencil and you used to colour in the little points to make basically the digital code. And then the way it worked was the card went into the card reading machine. I think these were big IBM card reading machines. And they had little sensors, had an optical sensor, and it could determine whether you'd filled in that hole. And I think some of them worked actually by electrical conductivity because of the actual lead pencil. So you had to colour these really, really carefully. And you lived in fear of having your entire program in a deck about this tool accidentally dropping on the floor because you had no way of sequencing these cards. So if you dropped your cards on the floor, you literally had to go through them all again and reassemble them all. But and then they go through the machine, you'd send them off and they'd come back the following week from wherever this computer was. I don't know where it actually is situated. And it would have the actual instruction you thought you'd written printed on the top of the card. And the big disappointment was if card 5 said something different from what you expected. You know?
I suspect the Hong Kong primary school exam was probably marking was on that type of machine.
Oh, really?
Because I remember when we were in exam, we had to use a lead pencil to A, B, C, D, the multiple choice. You have to color it in the lead with your A, B, C, D, and you have to color it really nicely so that it will.
We call them scantrons in America, in New York.
Really?
Scantrons, like a green kind of slip, and then you would use lead pencil.
Well, it was not a green slip, but it was definitely you have to fill in the exam with the lead pencil. Yeah, it was actually a white paper with a lot of red boxes, and then you have to fill it in.
It wasn't until late. I should say Brentwood had a fabulous centre called the Applied Science Centre, run by a guy called Alan Robinson, absolutely fantastic mentor, very important to me. And it allowed us to do all sorts of technology. So I did geology and astronomy and applied science and computing, all focused there. And eventually one day I remember a box arriving and we got our own PDP-11 processor, which I have to say was a very exciting day for the school.
How interesting. So that's the real reason why you're not an accountant now.
I suspect so. I think it also is a reason why I believe in mentoring so much, because I've had people who've mentored me through my life in technology, and I so much appreciate their input. I want to pay that forward.
I think so. I think mentorship it's very useful. I think there's two pivotal point in your life that you really do need mentorship. Is when you in school when you're picking your subject. I think it's a very confusing process. People say, which subject should you be picking? And you know very little about the actual job, except you probably watch it online or in a film, that has nothing to do with real life. And then the second part is when you first come out of college, when you first started at work. I think it would be very helpful to have someone to actually look at you and see your career, how you develop your career.
I think that's right. Those are key points. But I also think mentoring can be helpful almost at any stage.
Of course, yes.
When you're just to either help you just keep carrying on or changing direction or just a bit of encouragement or a few pointers.
Yeah. So if you want to mentor someone about AI right now, what would you say?
Now, this is interesting. I was giving a talk for Ron, who you've also had on this, and I got asked a question by a student, question which I think is really what you're asking. And they said, I really want to get into AI. I really want to know what I should study. And I said, well, it's always fun to play with the latest tools, but try and understand what's going on under the hood. So a little bit, if someone says, I want to learn about cars, what should I do? Probably the wrong story is to say, well, get in a really, really exciting car and drive around a lot. You'll learn something, but you won't learn a lot. Probably you want to lift the hood. You want to look what's underneath. And you want to know what's common between these tools. How are they the same? And then how are they different?
But what if someone arguing say, no, we don't need it anymore. We can just drive now.
if you want to know what the next iteration's going to look like, you need to know what's under the hood. Unless the only difference in the iteration is a spray paint. Okay? So if the only difference in the iteration is that they're going to make the steering wheels slightly larger and spray a different colour, then to be perfectly honest, everything you've learned is everything you need to know. But if you want to understand what the real differences are between, say, something like Hermes, which is one of the new orchestration platforms, versus OpenClaw, you can go on YouTube and see lots of videos where they say OpenClaw versus Hermes. But if you don't watch something like that and understand what's actually going on under the hood, then the only difference between them is the logo and the colour. And that actually doesn't really teach you anything. It also doesn't show you the way it's going. So there are now other tools that are put together that may, in certain areas, be smarter and more suitable for you, in other areas not. And if you don't know what's underneath or how it's working, then you're missing out. You won't be able to make the right decision.
We mentioned earlier on about different sizes of model.
Mm-hmm.
And would you be able to tell us a little bit more about that?
Well, this is a very interesting area because there's been some work done on small language models. There's been some work done on large language models. And then, of course, relatively recently, there have been things like Mythos coming along and some really huge models. But, there's a model with 1 trillion parameters, but you only light up a fraction of it every time. So in a sense, that's what they call an MOE, a mixture of experts. And in the mixture of experts, probably each of those experts could be considered to be a small language model. So we've got this continuum, as it were, from just a small language model, which, as I mentioned before when we were talking, you might do for a specialist compliance analysis or a specialist analysis on something in a database, to the large language model, which, unless you're particularly tuning it, you're trying to get it to answer everything, really. And then you get the mixture of experts, where in that situation you've got certain parts of it know about certain things, and you've got some layers at the top that are reasonably smart at routing your requests to the right smaller model. So, as you can see, that's a whole continuum of size. But as we move towards what are called edge models, which are really models that are not running on some big computer with you accessing by the server, but you're running directly on your phone, then we have to get those smaller, because we're not going to be walking around with 32 gig NVIDIA cards in our pocket. The cooling alone would be unpleasant. So that's not going to happen. And there's no real reason for it either. There are ways around this. So I think smaller models are going to be important for smaller devices, for automation. There are people running Hermes on Raspberry Pi boards now. So there's lots of there's a move towards making it smaller. And I think that's a very healthy direction.
Isn't it better to run it on the biggest model, everything on cloud, and then I don't need anything in my office?
I think it depends what you're trying to achieve. One of the things that's perhaps unusual about our compliance solutions is we design them so they can not only be hosted in the cloud, but actually hosted in your office. And even the LLM, even the AI side of it, can be hosted in your office. So you as a
what does it mean by hosting it as?
What that means is you will have a number of boxes in your office, and when we talk to the system, we only talk within your office. The information never leaves the office. Now, in a compliance situation, that might be really important, because you can then really, really securely protect that and make sure that no one else can access it. And of course, there's a lot of important confidential information. There'd be no need for compliance if there wasn't any interesting information with there. So that's important for compliance. But living in Hong Kong, we have another issue to consider, and we don't discuss this very much, but there are a lot of geopolitical issues associated with AI, and I don't think, from my reading of it, I don't think they're going to get any less in the near future. So, as AI it becomes an issue, not only how well it performs, but where it comes from, we may find ourselves in Hong Kong not being able to access everything.
Because there's a lot of patriotism coming up at the moment, right? It's my technology, it's my AI. You cannot use it.
Yeah, there are lots of different reasons why it might happen. But it's, in a sense, it doesn't really matter why it happens, because if you go onto the web and you say, I want to use this particular program, a very good example would be something like Claude. The truth of the matter is you can't use it in Hong Kong. You're actually blocked from using it in Hong Kong. Now, there are ways to get to it, and people use VPNs and other things like this. But as a business, that's a pretty risky proposition. Mm-hmm. You haven't got any of the service level agreements. You haven't got any confidence that your data isn't going to be looked at as it goes along the VPN. You haven't got any real confidence that will be there when you really need it.
So that's when closed system comes in.
That means that you've got complete control of the availability as well as your own data. And we can offer that. Now, not everybody needs it. Some people might be perfectly happy to have it hosted on AWS in Singapore, AWS in Texas. I don't know if it's Texas, I'm just guessing. But anyway, it's perfectly reasonable that people can make those sorts of decisions, but we are offering that choice.
Do you have a sense of, like, percentage-wise, your prospects and customers, how many would want or require on-prem versus they're okay with cloud? Do you have a sense of that yet? Or?
I don't really want to go there because everybody has their own reasons and all those reasons are valid. So I'm not trying to push anyone in any particular direction. I think it's important to offer it, and then people can make their own decisions. So it's a tough one. It's a tough one to answer, to be perfectly honest.
Yeah. The other thing that I've observed is, like, the newer Qwen, like 3.7 models. Mm-hmm. They were open source, but then 3.7. It's closed source in reality. So to your point about geopolitics, it's sort of like there's some movement there in terms of what historically has been very open source from China. They're actually sort of closing ranks and doing closed source. Is there a particular small model line that you like, or is it still an area of exploration for you, or yeah?
Yeah, I mean, personally, as opposed to corporately, and I think I'll just speak personally, the Gemma 4 model is very good. Yeah. DeepSeek, of course, is very good, and that's an easy access over Llama Cloud. I'm not too sure I agree with the Qwen. I think Qwen 3.6 I tend to use as well at 27B. That's pretty good as well. I'm wondering whether some of the models that are staying closed are really staying closed because they're just so huge. No one's got the hardware to run them. But we'll see whether that's the right theory or not if things start to get closed. I don't see why those models should be closed to Hong Kong. But
closed source as in they don't share the weights. Yeah.
Yes, they don't share the weights. Yeah. I do see a move.
What do you mean by sharing the weights?
Well, this is a really good point, because to me, sharing the weights is sort of like half sharing, because you still don't really know how it works. You don't know how the lab got there. They're just letting you run their model on your own hardware. But there's still a lack of understanding and reproducibility of that model. So there's some labs like Mistral that do a better job of sharing their whole training curriculum and their data. And then there's other ones like, most of the Chinese labs, they'll share the weights, but they won't really, and they'll even share some of the techniques, but you wouldn't be able to reproduce their training curriculum and create that model again.
No, but so let me answer your question about what the weights are. If you think of a neural network, which is in essence what we're talking about, there's nothing new under the sun in a sense in AI. So a neural network, you've got lots of little processing points that effectively act as summing up the signals. And each of the signals that go between each of these little points has a weight. And that weight is adjusted to cause a point where that neuron point will actually fire and send another signal into the next one. So the value of those weights is analogous to memory. So in some ways, a neural network is a huge content addressable memory in some ways.
So when you're talking about weights, in some sense, like when you're throwing the dice, you put in some sort of bias.
Yes, that's right. So these are all the biases, all the weights. Yeah. Now, you've probably heard of a temperature of a neural network. You heard of the temperature? Okay. So if you bring the temperature, if you imagine that basically you put whatever your input vector is in, and that will propagate through down finally to suggest that this is the correct token. actually what will happen is you'll get a selection of possible hits. And if your temperature is 0, then you can assume that you will always pick the same token. You shouldn't really be able to reproduce the behaviour of the thing at a temperature 0. If you increase the temperature, you're saying have a look around at all the possible tokens that fit within that temperature, in other words, that difference, and then randomly pick one of those. And then you start to get a lot more randomness. And
so when a company is sharing the weights, then it's actually showing you like what kind of bias they put in.
Yes, well, they're showing you all the actual final memory results of the network.
But they didn't show you how they train this network.
They don't show you the test set that generated that. And even seeing the test set isn't enough, because in many situations, the order in which your test set is put together makes a difference.
Very interesting.
Like magic. Yeah.
Well, is that why people would talk about how the LLM is in a black box?
Yes, I think the reason the whole phrase black box is quite an interesting one. Obviously, it's become understood as I cannot see inside what's really going on. Actually, you can see what's going on with an LLM. It's just it doesn't make a lot of sense. Because as you sort of ripple through, now Anthropic did some really great work on this, where they showed some pictures of whole networks and bits that lit up and everything. And there's a little bit of that going on, back to the person with the preposition damage, specific areas that mean specific things. But that doesn't always show up, and you can't always interpret. So, but the black box really means that I put something in it, and I really don't know how it comes out the other end. And this brings me back to what you should learn. Should look in the box.
But at this moment, a lot of times that people would say, for the sake of saving time, we don't care what's going on in the black box, just result oriented.
Yeah, I mean, I think it isn't necessary for everybody to know how Excel works, but you do see some very silly mistakes made by people who don't understand how it works. So if you want to go further than the exact use case the person was putting it together for you, you're going to need to learn a little bit under the hood.
So, well, 6 months ago, the idea that knowing some sort of assembly language is always going to give you a little bit of cutting edge. Now, 6 months later, most people are saying that, I don't need it. I can just wing it. Are you belongs to a team that still, it would be better if you know something?
I wouldn't start learning assembly language now, let's put it that way, except, here's the irony. If I go to AI Tinkerers, and big call out for it, I haven't had a chance to call out for AI Tinkerers, but I should. AI Tinkerers is a fantastic group, and I would recommend it. It's a great way to come and have a look at what people are doing, and it's a great way to find people who are interested and can tell you stuff. But we're having conversations that aren't about sort of, what colour box does that come in? People are talking about how much RAM do you need for this, and why do you need that much RAM, and does this chip share video RAM as well as program RAM? And these sorts of conversations, and they're not just Jeremy conversations; they're really important conversations. So I run a local LLM. I run Quen 3.6 27 billion connectors in my house, and I run it off a horrendously modified G15 with lots of memory and other stuff and an NVIDIA card and everything. And I have optimized it all so that it works properly. I know how to do that because I have an engineering background. But if you do not have an engineering background, understanding how a GPU works, understanding the trade-offs between running some of it within local memory, some of it within the graphics memory, how you allocate those layers, you need to know that stuff. Otherwise, you can't do that sort of thing. Now, does everybody need to do that? No, of course not. So it depends on what level you want to know about AI. Arthur C. Clarke had a wonderful, wonderful quote, and that is he said that anything from a sufficiently advanced technology will look to us like magic. And
yes, cool.
And actually, the next AI project will probably look like the magic as well, unless you understand what's going on a little bit under.
How would they be able to do that? Go to school or?
We've now reached the democratization of this information. There is more information than you could possibly read on YouTube. If you get onto LinkedIn, there will be someone every day telling you about one of the big companies has got a new free course. You can get free certification from Google. MIT does a lot of great courses. Honestly, there is so much material out there.
But there's so much.
Nobody has the excuse of saying, I couldn't find anyone talking about this issue.
But there's so much material out there, but you don't really know what are the good materials, though, you know?
Come to Tinkerers, ask someone who knows, they'll tell you. No problem.
You can also just ask AI too.
Yeah.
Yeah.
Sort of recursive, yeah.
It's absolutely true. Yeah, get onto Gemini, which you can download on your iPhone free. Talk to it and say, what should I read to understand how you think?
Exactly.
We could try that. We'll try it later.
Try it later, download it and see what Gemini tells.
Oh, no, it's already on my phone.
Yeah, so, do you think, are you optimistic about this whole endeavor?
I'm optimistic that we have many more wonders to see. If you're asking, am I optimistic that as a society we'll handle this well? I genuinely believe we're entering a new industrial revolution. And I think if you'd asked someone on the other side of the previous industrial revolution what they wanted, they wouldn't have told you they wanted an automobile. They'd have told you they wanted a faster horse. Mm-hmm. And I think we're still at the faster horse stage. And I think many of the guesses of what we think the future looks like are faster horse guesses. So we'll just have to watch and wait. But I think it requires some really smart people, much smarter than me, to think this all through and understand what society we build with it. It's going to give us huge capabilities, but people are still going to want to do things that satisfy them in their life. People are still going to want to have a goal and a reason to get up in the morning. And we can't build a world, in my view, that removes that desire. If we do that, we will be the worse for it. But fundamentally, I'm optimistic.
So maybe we'll come back like next week and look at this faster horse. Thank you, Andy. Thank you so much. And please come back again.
Thank you, Tanya.
Thank you.
Awesome.
Thank you.
All right, let's do this.